and welcome to Pale Blue Pod, the astronomy podcast for people who are overwhelmed by the universe but still want to be its friend.
Yes, it's true. I'm Corinne, friend of the universe, fun person, excited to be here.
Yay! I'm also excited that you're here. I'm excited that we're here together, Corinne. Hello, everyone. I'm Dr. Moiya McTier. I'm an astrophysicist, a folklorist, and a friend to the universe.
Yes.
I think we can all agree on that. And I love thinking about the universe when I am surrounded by something that is firmly rooted in the earth, namely flowers. Because today we are recording this episode in a beautiful rose garden.
Stunning. I love gardens.
I love gardens. I love roses. My mom's name is Rose. It's Rosemary.
Yeah.
She's always gone by Rose. And this garden is especially beautiful. There are roses of all colors, of not all shapes, because roses tend to come in that one shape.
But there's garden roses, there's spray roses. I only know about this from my wedding. Just like I did the flowers myself to save a lot of money.
Oh, wow.
So I was just like learning all these kinds of flowers to like understand what to order.
Oh, did you end up ordering one of those types of roses?
I ordered garden roses and spray roses because spray roses are tiny, and garden roses have like many petals and like get kind of round and big.
Oh, nice.
It was definitely like a hyperfixation like hobby that week.
Yeah, but it smells amazing where we are. It looks beautiful, and it sounds like we're in a garden. There's a breeze. There are people laughing somewhere else. We found a little private corner to record in. But while we're sitting here among the roses, we are going to be talking about another scientist who is no longer with us. We are talking today about Dr. Arthur C. Walker, who was a solar physicist and a pretty decent-seeming astronomy guy.
Yeah, he's really cool. I did notice that some sites have him as Arthur B.C. Walker.
Yes, which I like. When I tried to look for his papers, I saw A.B.C. Walker.
That's so fun. Oh, wow. Top of the alphabet.
Good stuff. Good stuff. But we're going to talk to you, listeners, about his life, about his work, about the legacy he's left behind, and we have a little game for you at the end. But let's start with where Arthur Walker came from and what his roots are, because he himself is like a rose in some ways.
Oh, yeah. He smells great.
It smells good. Well, not right now.
Yeah, maybe not right now. Yeah, okay, I'll tell you a bit about where he's from. He was born in Cleveland, Ohio.
Whoop,
heard of it?
I've heard of it. There's a Hall of Fame there, but I can never remember which one.
Ooh, neither can I. I don't even think I knew that.
Is it Rock and Roll?
I know very little about Ohio.
It is the Rock and Roll Hall of Fame.
Rock and Roll, of course. I know, if my husband's listening to this, I know the Baseball Hall of Fame is somewhere in New York, I think.
What do you mean if? Eli doesn't listen to every single episode of Pale Blue Pod.
That's such a good question. It's kind of a silent agreement, and I don't always read his newsletter.
You mean you read every single
I read
newsletter.
Every single issue. I like every issue on Substack.
There you go. There you go.
Okay, so Arthur Walker, born in Cleveland, Ohio, in late August 24th, 1936.
Summer baby.
Summer baby, late summer. His dad is from Barbados, and I'm pretty sure his name is French, and I'm going to butcher this pronunciation, but it is spelled like Cuthbert, or Cuthbert, Cuthbert, and I did look up a French pronunciation. I've immediately forgotten it, but it sounds that I've never made.
Look, no one is coming to hear Pale Blue Pod episodes so that
French
we can pronounce French words correctly.
And thank God. That is not what we're here for. But you should look it up. But his mom's name was Hilda, and his dad was an attorney, like I said, native of Barbados, and his mom was a social worker. And Arthur was the only child of the family. And when he was 5 years old, he moved to New York City.
Hey, that's where I live.
And that's where I'm from. He attended elementary school in Harlem. Maybe it's near you, Moiya, actually.
It probably is near me, yeah.
And he loves science, and both of his parents supported that for him. But a lot of the research I did was that his mom was especially supportive of him exploring science and really key to the development of that. And she apparently organized parents at his elementary school to fight. There were teachers who were kind of leaving during the day to run errands.
What?
And isn't that crazy?
That's wild. Yeah, I guess that would have been what, like in the 40s, early 40s?
Yeah, like he was born 36, so it must have been in the 40s. In my head, I'm like, well, that must be like during lunch or something, but maybe not. So she kind of organized a group of parents to stop that from happening, to kind of complain enough to keep the teachers in schools, which I have to say makes sense. You're going to want the teachers in there.
I can get behind that rallying cry.
Yeah. But apparently this led to them transferring to a new school outside of their district. So I don't know how successful that campaign was, but I think it's noble that she was like, we're not going to stand for this. So in his new school, he discovered science and like he supposedly loved the library and like got to read a lot and learn a lot. And his new goal became to study the universe like Albert Einstein.
Aww.
It's very cute. And his mom encouraged him to take the test for the Bronx High School of Science, which is a great school in New York.
I've passed that.
And Arthur's first love was chemistry, but apparently he had some teachers who kind of discouraged him. And his mom stepped in again and told the teachers that he would study whatever he wanted, whatever he liked, which I love.
I love Mrs. Walker. I can't imagine there were that many Black students in the 1940s and 50s at the Bronx School of Science.
I'll bet it's still low to this day because, well, maybe not Bronx High School of Science, but there's been a lot of like articles in the Times. Eliza Shapiro writes about this a lot of just the whiteness in New York City schools, especially like the specialized test schools. And yeah, you should definitely read about that if you can. New York City is like the most diverse place, I think, in the world. I don't know if that's true, but it is weird how segregated the school system can still be. But
well, fuck those teachers.
I know.
Because I had some of those types of teachers in my day.
I was going to ask you if you had teachers who like were not supportive of you and your interests.
Oh, 100%. My guidance counselor told me there was no point in applying to Harvard. There were many teachers who just told me that I wouldn't be able to do the things I wanted to do, despite the fact that I was easily the top of my class after skipping 10th grade.
Yeah.
This is unfortunately not unheard of.
What are they on? What's
Racism?
going on? Yeah.
Race. They were on white supremacy.
That's exactly right. Yeah, I had some not so great teachers, and I luckily had some good ones, but it was definitely not as hard a battle for A, being white, and B, my interests were like art and English, which is just more gendered woman anyway. So.
Yeah. But also facing other issues like budget cuts to the arts.
Oh, totally. It was always like, are we going to have this program next year or not? Okay, so Arthur's first love was chemistry, but Hilda stepped in and said he'd study whatever he wanted, and he decided to pursue physics, and his mom encouraged him to apply to the Case Institute of Technology in Cleveland, so kind of back where they started. And in 1957, he completed his undergraduate studies at the Case Institute of Technology, and he earned his bachelor's degree in physics, and he kept going on to study more, but I won't spoil it yet.
No spoilers. That was 1957 undergrad. He then got a master's in 1958 at the University of Illinois and then stayed there for his PhD. I don't know if there was more you wanted to talk about of his personal life before. No,
I wrote a fun fact, but I think you already know it because of where we're recording today.
Yeah, a little bit.
He loved growing flowers.
Yeah. Because we like to pay homage to the topic of the episode when we choose our recording location. So I thought Arthur would want to be with us in this rose garden.
That's very sweet.
He's at the University of Illinois starting in 1958 when he does his master's in physics stuff. And then he stays there for his PhD program. He graduates with a PhD in 1962. His dissertation was titled Photomeson Production from Neutrons Bound in Helium and Deuterium.
A must-read.
a must-read. A page-turner.
An absolute
This is a beach
turner.
read. cannot put this down. Do any of those words sound familiar to you, Corinne?
I mean, I know helium from balloons, famously.
Yes. Yes. Great. Deuterium is just like a heavier version of hydrogen. So a normal hydrogen atom has one proton and one electron, but deuterium has that plus a neutron in the nucleus.
And then I know the word neutrons and I know the word production.
There you go. Yes. I'm sure you also know the word bound. Photo, meaning light. Meson is a particular type of fundamental particle. And so basically the idea, the gist of his dissertation was that he was trying to study the radiation that gets produced when particles called gluons bind protons and neutrons in the nucleus of an atom. So we've talked about this before. We have an episode where we explain all of the four fundamental forces in physics and astronomy. One of those forces is the strong nuclear force, which is responsible for fusion, like the actual combination of protons and neutrons in atoms. Like this is what our sun is doing. So he was studying that.
Fun.
Because he's doing this in the 60s, early 60s, when we didn't necessarily know that much about how the different nuclear forces work and what byproducts they make. After 1962, he then joins the Air Force, like immediately after graduating, and he works in their weapons lab. I put a little frowny face in my notes because I will always be sad about the connection between academia and the military-industrial complex. Unfortunately, that tie is quite strong, and we can see that going back all the way, at least, to 1962. So yeah, this dude, he goes to work in the Air Force weapons lab, and he helped develop instruments that were specifically supposed to study something pretty sciencey, at least. They were studying the Van Allen belts, which are types of radiation in the Earth's magnetic field that can interrupt satellites. So many research astronomers are glad that he did that work. I'm sure many defense contractors are also very glad that he did that work because satellites often are associated with nefarious industries. Okay, enough about that. All right, so he was there for 3 years, and then he had done his commitment to the military, I guess. I didn't realize it was that short.
Oh, yeah, me neither, but sure.
Yeah. Sure. So he's there for 3 years. And then in 1965, he started working in the space physics lab of the Aerospace Corporation, which sounds like such a made-up company to me.
It definitely does. It feels like a company they make up for the background of a movie.
Yes, exactly. The Aerospace Corporation. Apparently it's this nonprofit research organization that does some government work, but a lot of civil and commercial research for anything having to do with aerospace. And while he was there, he studied the sun's atmosphere and the upper Earth atmosphere, specifically in the high energy part of the electromagnetic spectrum. So he was looking at UV, ultraviolet, and X-rays in these two areas. And he was there at the very legitimate Aerospace Corporation for 9 years.
Long.
Cool. Yeah, I spent a long time studying the sun and our atmosphere. And then in 1974, he joined the physics department at Stanford University as an associate professor, and he was there until his death in 2001. So he started out as an associate professor in the physics department. By the late 80s, he was a joint professor with physics and applied physics. And he had his hands in so many departments at Stanford. We might as well just call Stanford the Arthur C. Walker University, because he was all over the place. He chaired the astronomy program, not an actual department, but the astronomy program from 1977 to 1980. One of his responsibilities in the astronomy program was to teach some astronomy classes at various levels, from basic to advanced, and to lead observing nights at the nearby student observatory. But he was also involved with the Afro Studies program and departments. He was the longest serving advisor on the committee of Stanford's Afro Studies program.
Cool.
Yeah, like he was a really interesting guy who clearly wanted to be pretty interdisciplinary, and I respect that.
I was going to say, I feel like that must be very relatable.
Yes, I am here for people who can't choose one straightforward path. Let's talk a little bit about the work he did while he was at Stanford in the physics departments. So in the 80s, he started collaborating with some peers in the materials sciences department. And that's important because he, as a physics person, knows all of the basic science and the optics of how telescopes work, but he doesn't know how those actual materials work, and he doesn't know how to make new materials to create better telescopes. So he starts working with people in that department because collaboration, very important to innovation. Mm-hmm. Together, they started to develop filters for X-ray telescopes to study the sun's corona, which is the wispy outer atmosphere, like the very outer atmosphere of the sun. That's the wispy streaks that you can see if you are lucky enough to be in the path of totality for a total solar eclipse. And this was a new technique. Most telescopes work by having light reflect off of a mirror into some kind of data processor, like a CCD, which is a charged coupled device, which essentially just tells you how many photons are in each pixel of your camera. But that doesn't work for X-ray observations because X-rays are so energetic that they don't reflect off of a normal mirror. They just pass right through it.
Spooky.
Which is tricky. Spooky. Oh, yes, it is spook. It's the early
season.
Spooky season. So they used to have, or they still do, but a lot of X-ray telescopes worked by having the X-ray photons glance off of a mirror. So you had to approach the mirror with a very specific angle so that like a shallow enough angle that the X-ray photon would just graze off of it.
Oh, okay.
Yeah, so those are called grazing incident telescopes or something. But they wanted a way to have an X-ray telescope that worked with the light just going directly into it, which is called a normal incident telescope. Normal is, I think we talked about this in the constellations episode, but normal is a physicist's fancy way of saying perpendicular or at a right angle.
Okay. Yes, I think you have mentioned that.
Mm-hmm. So they figured out how to use a bunch of different layers of very thin films stacked together to create a normal incident X-ray telescope. And they put those instruments on a bunch of rockets and then launched them into space so that they could be above Earth's atmosphere, which blocks a lot of ultraviolet and X-ray light. And they observed the sun in these ultraviolet and X-ray wavelengths for the first time. We had coronagraphs starting in the 1700s. Coronagraphs are instruments that block the main body of the sun so you can study the corona, but we were only studying them in the optical and the infrared. And it wasn't until Arthur Walker and his buddy in the material sciences department developed these films that we could study the sun's corona in the UV for the first time. And we took images. And they then launched a bunch of other instruments that could observe the corona in slightly different wavelengths. So they then had this data of what the sun's corona looks like at different wavelengths. And when you have that, then you can do spectroscopy, which is very cool. And so at the end of Arthur C. Walker's life, he was developing this technique to use X-ray spectroscopy to map out 3D structures of celestial objects. And after he died, there were other researchers in the physics department at Stanford who took that technique that was starting to be developed and applied it to dark matter, because dark matter out in space exists in these clumps or these clouds that we can't see. So far, we can only study dark matter based on its gravitational interaction with luminous matter. But with these X-rays that are being emitted by stuff around the dark matter, you can map out the shape of this dark matter cloud in the middle.
Oh, cool. Mm-hmm. Wow. The importance of interdisciplinary collaboration.
Yes, exactly. And I love all of the steps that went into that. There's no easy way to link Arthur Walker, a solar physicist, going to the material sciences department, all the way to mapping out the 3D structure of dark matter in our local cosmic neighborhood. Like, those two things don't seem like they should be linked, but because science is something that is inherently creative, they figured it out.
Yeah.
I love that. Hey friends, it's Moiya here. Corinne went off to go sniff some of those beautiful roses, so I wanted to take the time to say thank you to all of our amazing patrons who support the show every single month financially. So thank you, as always, to our sun-like stars, Sharn Llewellyn, Lissa, and Peyton. You're all amazing. Thank you so much. We really appreciate your support. And also a big thank you to our newest Red Dwarf star, Lula Hayes. I hope I'm saying that right. Now that you're a star in the PBP universe, I really hope that you are enjoying your magnetic flares and your convective heat transfer. And if you don't know what that means, then go listen to our episode about star types. You too can support us. You can hear your name on this pod, and you can make it to our patron star chart, all by supporting us on Patreon for just about $1 per episode. And that's even less if you sign up for an annual membership, because you will get a 13% discount across an entire year if you pay up front. That is 1 percentage point for every constellation in the zodiac, because we love Ophiuchus over here. You can find that star chart, the Patreon info, and more at our website, palebluepod.com, or you can go right to patreon.com/palebluepod. And if you can't support us financially, that is totally fine. We love you. So does the universe, because you are still space. But there are other ways that you can support the show. You can rate and review the show on whatever podcast app you prefer. That helps other people see that we are a good show that they should spend their precious time listening to. You can also share the show with your friends. Really, any way that you can get our show into more ears, that is a great way to help the show grow. So I hope that you can do one of those things. But if not, we love you. You're space. Moving on to a podcast recommendation. This is coming from the Multitude Collective. That is the collective of independent podcasts that Pale Blue Pod is a part of. But this is also a bit more personal for me, because I host another show. And if you are enjoying Pale Blue Pod and you want to hear more of my voice in your head, then you should check out my other podcast, Exolore. It is a show all about facts-based fictional worlding. So how do you build those amazing fantasy and sci-fi and historical worlds, but based on a foundation of facts and science? Sometimes I invite a guest to tell me all about their favorite world from TV or books or video games, and then we analyze the rules of that world, figure out what we like, what we don't like, and where they probably could have improved a little bit. But usually my guest and I imagine a brand new fictional world from scratch, just with the information we have in our brains. So on the show, I have built out a world that doesn't orbit a star, and I did that with 3 blind guests. So sight wasn't the default on that world, and it was really beautiful. I've imagined worlds where birds rule from their mountaintops between parties that would put Jay Gatsby to shame. And I've created races of magic-wielding spiders desperately trying to hold their crumbling planet together. I laugh and learn something new in every single episode, and I think you will too. So search for Exolore, that's EXOLORE, in your favorite podcast app. New episodes come out every other Thursday. Again, that's Exolore, EXOLORE. I would love to see you over there.
Climate change is going to require collective action. But how can individual actions make a difference? On a new episode of Life Kit, we're walking you through what sort of climate-friendly choices can make an impact in your life and the lives of others. Listen to Life Kit, part of NPR's Climate Week, wherever you get your podcasts.
All right, Corinne is coming back now with, oh, that's a whole bouquet of roses. So pretty. Okay, but let's get back to the show. Also, while he was at Stanford, he served on a bunch of committees, not just at Stanford, but with NASA, with the National Science Foundation, and with the National Academy of Sciences. Many of the bios and tributes that I read about him that were written after he died said that he was a gentleman scientist and that he was always willing to take on new work, whether that was mentoring a new student or serving on a very time-intensive and labor-intensive committee. He kind of just was always down, which is nice. looking back, I imagine he felt the need to always say yes because he understood that he, was a black man in this industry that is dominated by white men. But good for him. He stayed busy. One of these committees was not necessarily responsible for, but like largely influential in combining two observatories. One, the Kitt Peak Observatory in Arizona, and the other, the Sacramento Peak Observatory, I assume in Sacramento, California. And those two things combined into a united National Solar Observatory. He was on that committee in like the 80s and the 90s, but the National Solar Observatory has been around since the 50s or 60s. So he was bringing these two observatories into that union. And he was also on a committee that helped establish the Gong Project. Because we're astronomy people and we love an acronym, actually is a very simple, straightforward acronym. It stands for the Global Oscillations Network Group.
That's like one of the most straightforward ones we've done.
It really is.
I don't see any letters in the middle of a word capitalized.
Yes, they like staying true to what an acronym is actually supposed to be. Gong. They installed 6 different identical telescopes in countries around the world so that you could essentially have 24/7 observations of the sun from identical telescopes, so you didn't have to figure out how to account for the differences in the telescope, just the differences in their location. They were installed in 1995, and they were studying or collecting helioseismology data. So helio means the sun. Seismology means like acoustic waves or pressure waves moving through the sun that kind of make it dance a little bit or pulse a little bit. And so helioseismology data is studying the pressure or acoustic waves passing through the body of the sun. That's his time at Stanford. And because he was working with NASA, with NSF, and with these other agencies outside of Stanford and kind of going outside of academia a little bit to these organizations and institutions, he was known as like an astronomy person who worked well on committees. And so he was one of the 14 people who were put by President Nixon on a commission to examine what happened during the Challenger explosion in 1986, which is not something we've explicitly talked about on the show before, but I feel like we will at some point. Like, we must.
Yeah, it's so tragic. Yeah, the Space Center I worked at was a Challenger Learning Center, which was founded in the wake of the Challenger explosion and in honor of Krista McAuliffe.
Oh, she was the teacher, right?
Yeah, she was the teacher astronaut for that mission.
R.I.P. R.I.P. So there were 14 people who were tasked with figuring out what the fuck went wrong and what can NASA do going forward to be safer. And so they wrote a report detailing the cause. They figured out that it was the O ring, so this ring in the rocket that had this very specific range of temperatures where it could actually seal what it needed to seal. And on that day, they were operating just outside that range of temperature. And it seemed to be kind of like a cascade of failure. We'll talk about this in another episode. But they put in their report that we can ultimately track it down or trace it down to one thing, this specific O-ring on the rocket. But if you zoom out, you can see that there were many failures leading up to this point. And so their recommendations for NASA going forward were that you need to have like redundancy in your checklist. If all of your things that you're monitoring are like just inside their realm or like their range of working, like if they're just inside the temperature range or just inside the pressure range, if every single thing on your rocket is just within that acceptable range, don't go. Don't go.
That might not be good.
Yeah, and I think they also put in like other fail-safes so that NASA doesn't have to deal with something as tragic as the Challenger explosion again. What are you thinking of Arthur Walker so far?
I really like that he seems kind of, I don't know if he would describe it as this, but it seems like community-oriented or like likes the, this continued effort to be improving or like working with people. I feel like science and a lot of writing and art can be kind of isolating, especially as a researcher, but he seems to be involved with other people.
Oh, nice.
Or working with others.
Yeah, absolutely. We've seen that when he goes and he collaborates with the material sciences people. He goes and he collaborates or works with these other industries outside of his home institution. Yeah, I can definitely see you getting that communal focused vibe from him. And it shows in the legacy that he has left behind. One thing that comes up in every bio that you read about him is the way that he mentored students coming up through Stanford, many of them women and underrepresented like racial and ethnic minorities. So over his career at Stanford from 1974 to 2001, he had 13 grad students that he formally mentored. The first of his grad students, his research grad students, was Sally Ride.
Sally.
Sally Ride, who we talked about in our episode on the 6 with Lauren Grush. She was the first woman astronaut that America sent into space. So he mentored her as her grad advisor and 12 others, but he informally mentored like 40 Black students who got physics PhDs at Stanford, which is twice the number of Black students that MIT had graduate with physics PhDs in the same period of time. And like, if you look at other schools in the country and that time frame, they just weren't graduating Black physicists. So it's really easy to see from this one data point that if you have a Black professor at your institution, your diversity efforts, like all the DEI initiatives that you put into place in 2020, like it works. Just have people of color in your space and they will bring other people of color to your space and make sure that they can thrive. Like, it's not that hard. It really is so simple. So good for him. He helped a lot of the vanguard people in our field. And I mentioned this before, that he was the longest serving member of the advisory committee for the Afro Studies program at Stanford. Through that role, he was also a mentor of sorts for Condoleezza Rice.
Oh, that's so funny.
I know. And I know I'm supposed to know more about who Condoleezza Rice is. I know that she's a Black woman who did politics stuff.
Yes, she served under George W. Bush's reign. I'm saying as if it was like... I mean, kind of. I just mean Condoleezza Rice worked under George W. Bush.
Yes. So, again, why would you ever think to connect this solar physicist and this politician?
Right.
It's because he had this community mindset. It's because he had the compulsion to interact with other departments, which is kind of rare in academia, where everything is so intellectually siloed in your own very specific department. So good for him. And good for her, because she seemed to have done well for herself.
Yeah.
And I was actually surprised that I couldn't find many awards named after him. He was given an award. NASA gave him some like distinguished civilian researcher award or whatever. That's not what it's actually called. But he did win some awards while he was alive. But I expected there to be more awards named after him going forward. But the only one I could find was this annual award given out by the Astronomical Society of the Pacific. And they give out every year the Arthur B.C. II Award, which is given to an outstanding Black researcher in astronomy who has demonstrated a commitment to actively promoting diversity in science. So they want to see people who have mentored a lot of Black, brown, and other underrepresented students, or people who have set up programs like research internships or mentoring programs or whatever to help those same underrepresented students. And that's given out every year.
I like that award.
Yeah. It was first given out in 2016. The inaugural recipient was, of course, the amazing Katherine Johnston.
We have an episode on her.
We do. I love that as we go on, we're just going to continue to be able to say, like, and we have an episode on that. Go check it out. Because that's what I see, like, Allie Ward doing on Ologies all the time. And it just feels so good when we get to do it.
I know. We have this huge bank. We're building out the universe.
Oh, I love that. We really are. We're building out the universe's knowledge bank.
Yes, exactly.
And that's the only award I could find.
I guess that kind of makes sense. It could be confusing if there's many awards after one. I don't know. Maybe I'm drawing a blank on awards named after people.
I mean, in all of our scientist bio episodes, we've had a couple of awards named after them. Like Katherine Johnston did, Carl Sagan did, Vera Rubin did. She had awards and a whole fucking telescope named after her.
Yeah, that's true.
I feel like at least with all of these instruments that he launched out to the sun, like we have the Parker Solar Probe named after a dude named something Parker who was a solar physicist. One of these days we're gonna have to send the Arthur C. Walker the second probe, you know?
Yeah, that feels inevitable.
I'm waiting for it. Okay, now it's time for little activity.
I think I know.
So usually for these scientist bio episodes, what I've been doing is playing a game with Corinne where I ask her to guess, is this a real paper title or something I have completely made up? And I started to make that game, Corinne. This morning, I woke up, I was super excited. I was like, I'm going to make something fun for Corinne today. And then I went on to ADS, the Astrophysical Data Management System or whatever. It is the repository of papers that I go to when I'm trying to find what our scientist subjects have written. And I'd like to preface this game with a PSA to everyone out there. If you want your child to be notable in the future, don't give them a boring-ass name. Because there are too many fucking Charles A. Walkers
Totally.
publishing papers in physics and astronomy. And I could not find more than one paper from him on the ADS site.
Oh, no. The game.
The game it was interrupted, but the game must go on. And so instead, I have here for you, Corinne, 5 actual paper titles by Charles A. Walker. And you have to tell me which is written by our Charles A. Walker.
Okay. So there are 5.
Why do I keep saying Charles Walker? It's Arthur C. Walker.
You're getting the C in there.
I'm getting the C.
Okay, so there are 5 papers, and only one is written by our Arthur C. Walker.
Yes.
Perfect. This is perfect.
And I really did. I went through, and it's only when you look at like the affiliations of the paper authors that you can tell if it's the right Arthur. And every single time I would
so
go
funny.
and it'd be like this guy at the University of London or like this guy in Stockholm, Sweden. Like
so they're all kind of benefiting from each other at that point where it's like, this could all be me.
I guess so. There's one Arthur C. Walker. I got it right. Thanks me. There's one Arthur C. Walker, and he's just like this quantum amalgamation of every Arthur C. Walker's intellectual property. I think some of these are going to be pretty easy.
Okay.
For you to guess that it's not this one. I'm going to tell you the one that it actually is. I probably wouldn't have guessed it. So let's just
Setting
go through.
me up.
The first paper title I picked because when it was the original game, I thought it would be a funny title that I could play around with. This is The Finite Difference and Localized Ritz Methods.
Huh.
And you don't have to give me your final answer until after you've heard all of them.
Okay, I don't
just
think
give me your thoughts.
I don't think that one's it. Ritz methods, I mean, if this was the traditional form of this game, I would say fake paper because it sounds like a Ritz cracker.
Right. It's spelled that way too, R-I-T-Z. And then I had to look up what Ritz methods are.
Yeah, I don't know what that is.
It's very confusing. It had something to do with like complex geometry in like the expansion of a flat plane. I don't know. I was very confused. It was one of those abstracts where I read the abstract word by word 5 times and I still didn't know what it was saying. I know each of those words individually, but when you put them together, it's nonsense.
It's like I'll be reading a book and like 3 pages in, I'm like, oh my God, I didn't take in a word of anything I've just read.
Yes. Yeah, but it was one paragraph that I couldn't get through, and I felt so dumb. Okay, so that's paper number 1. The next one this paper is called Optically Bistable Thin Film Interference Devices and Holographic Techniques for Experiments in Digital Optics.
Okay, mouthful.
It is a mouthful. That's the type of paper title that people write when, like, they really want one specific person to know what's in the paper.
Yeah. Yes, they're writing. It's a letter to somebody else, essentially.
Yeah. Yes.
When he was working on looking at the coronas, he did work with film, like we talked about.
He worked with thin films, yes.
So that's why I'm leaning towards this one, but we'll see what the others are.
All right. I love your intuition. I love the callback. You remembered those thin films. Good. All right. That was option number 2. Option number 3. Polarization by stability and high contrast switching in an isotropic nonlinear cavity.
High contrast switching.
Yeah.
I don't know what that is.
Me neither. Me neither. I
High
think,
contrast switching.
Again, I read the abstract, and the first half of the paper title is more reasonable to me. I think the switching is like the polarization of the light, and you switch the polarization of the light.
Okay.
I could be very wrong.
Yeah, the high contrast switching feels to me scary. Like, oh, unpredictable. What's going to happen?
They're switching. You never know what you're going to get.
I'm thinking mood switches, like,
You're not even. We got to touch. The switching is happening in an isotropic nonlinear cavity.
That feels gross. I don't like it.
Me neither.
I don't think he wrote that one. I don't think that's him.
Because you don't think he was dealing with cavity? You think he would only deal with low contrast switching?
Yeah, he seems like a guy who cares about linear cavities, not non-linear cavities.
The only cavities allowed here are linear. Yes. I actually prefer an exponential cavity, personally. Give me a logarithmic cavity, please. I'm such a fucking nerd. All right, option number 4.
A whisper to yourself.
Do you feel like you have had the time to properly take in option number 3?
Yeah, and it's still not for me, and I hope it's not for him.
Okay, cool. Option 4 is electron scattering in tritium and helium-3.
Well, we talked about helium at the beginning.
Yes, helium and deuterium, which is like a heavy hydrogen.
Huh. So maybe this was interesting to him.
Okay.
But it is short, and I don't know if that's a red flag or not.
I know, right? Because you don't know. Is he a succinct guy?
Yeah.
His dissertation title was so long.
Right. This one's a maybe.
Okay, so far the maybes are options 2 and 4. 2 because of the thin film, and 4 because of this helium.
But because you said that you wouldn't have guessed maybe his paper, I feel like it's going to be 3. And I don't know what the final one is yet, so maybe we can learn. Okay,
I'm excited for the final one. Option number 5. Pliocene and Pleistocene hominid-bearing sites from west of Lake Turkana, Kenya.
I don't know anything that you said to me. That Pliocene, is that a material? What is that?
No, I think these are both like eras, like the Pleistocene, whatever the dinosaur people talk about as their different eras.
Dinosaur people?
Yeah.
Oh, okay. It's like a period of ancient Earth.
Yes, a period of geological time.
Okay, that doesn't feel like his niche at all.
No, this is not. This is not from our Arthur C. Walker.
Okay,
I'll tell you that
sense.
right now. And when I saw that title on the ADS list, I was like, because I had narrowed it down. There are a lot of Arthur Walkers. I narrowed it down by the middle initials. I narrowed it down to only peer-reviewed papers. I narrowed it down to just astronomy. I narrowed it down even further to just people who had been at Stanford. And this paper kept coming up.
It wouldn't leave you alone.
So then I looked at the affiliations, because if you say, like, only papers that are affiliated with Stanford, the other authors can still be affiliated with Stanford. So I found this paper where one of the others was. It was so annoying. But I saw this paper about the Pleistocene, and I was like, I don't think this solar physicist wrote about that. Like, he was pretty interdisciplinary, but not that interdisciplinary.
He's not that interdisciplinary. Yeah, that makes sense, because I don't think that's for him. His hands are pretty full.
Yeah, so that's a mystery Arthur Walker paper, which leaves you with 4 options left, although you have already yourself kind of eliminated 2 of them.
I eliminated the Ritz methods, and...
You were iffy on the high contrast switching.
I am iffy on the high contrast switching. I think I'm going to go with thin film interference devices, because it seems like close-ish to what he had done.
It does seem close to it, doesn't it?
Yeah.
Yeah, but it's not it.
No,
it is not.
Of course it's not.
It's not our Arthur C. Walker. I also saw that, and I was like, how many Arthur C. Walkers can be working with thin film devices?
That's quite a specific niche.
Such a specific niche, but no. This was the Arthur C. Walker at the University College London.
Of course.
And so the real answer is electron scattering in tritium and helium-3.
My backup. And short and sweet. I love that. He had to just be efficient because he was doing a lot. He had a lot of committee meetings to get to.
You're right. Physically could not type out the titles of these other papers with
busy.
the measly amount of time he had available. Yeah. Well, congratulations, Corinne.
Thank you. I didn't get it right.
Through another bio.
I didn't get it right, but I did the test.
You did the test. Your intuition was there. If this were ranked choice testing, then you would have done very well.
I love not taking tests.
We should do ranked choice testing. Where if your first answer isn't right, because
your backup answer.
Yeah, because oftentimes when I was taking tests, I'd be like, well, I could do it this way and it gives me this answer. But if I go back and diverge and go this other direction, it gives me this. And if I could just present both, I'll tell you which one I think is more likely. I give you both. The second one is right. I get some points, but not as many.
I love that. You should get to argue with a teacher about the answers, too. If they don't want to do ranked choice, let me fight.
Let's turn this into a battle cage to get the grade. I would have done that. I would have taken on any of my professors in college.
You know, I wouldn't have, because I think I was kind of bored in college. Just enough that I was like, I just want to go. I'll do whatever you want.
Much like Arthur Walker, you were down. You were like, yeah, I'll do it.
Yeah, I'll do it.
Fine.
Just fill up my plate. And
Awesome. Any last thoughts on Arthur C. Walker and his life and his roses?
I feel like mentoring is such a rewarding thing. And I mean, I'm not a mentor, but I have loved any teaching I've ever done, and working with people who are interested in something that, you know, facilitating that learning is such a rewarding thing. And I love that he did it too.
Yeah. All the way until the end. So we should tell you that he passed away in 2001 after a pretty long battle with cancer, but he stayed on as a professor and a mentor at Stanford to the bitter end, because he cared about his work and the people he was helping.
So with that, wherever you are, whatever committee you're on, just remember that you are space.
Yeah. So are the roses.
Yeah.
Pale Blue Pod was created by Moiya McTier and Corinne Caputo with help from the Multitude Productions team. Our theme music is by Evan Johnston, and our cover art is by Shay McMullen. Our audio editing is handled by the incomparable Misha Stanton.
Stay in touch with us and the universe by following @PaleBluePod on Twitter and Instagram, or check out our website, palebluepod.com. We're a member of Multitude, an independent podcast collective and production studio. If you like Pale Blue Pod, you will love the other shows that live on our website at multitude.productions.
If you want to support Pale Blue Pod financially, join our community over at patreon.com/palebluepod. For just about $1 per episode, you get a shout out on one of our shows and access to director's commentary for each episode. The very best way, though, to help Pale Blue Pod grow is to share it with your friends. So send this episode, this link, to one person who you think will like it, and we will appreciate you for forever.
Thanks for listening to Pale Blue Pod. You'll hear us again next week.
Bye.